Hi, good evening to all of you. So, we will continue with the discussion on environment ecology, and yesterday we completed the discussion on global warming, climate change and the United Nations Framework Convention on Climate Change, 8 national missions related to climate change in India, and we have also discussed in detail what the world is doing and what in India we are doing to combat this problem. Now, today we will start discussion on yet another important environmental problem which the world is facing, and in this regard Kigali Agreement. So, ozone depletion as an environmental challenge is what we will take up for discussion, and in this regard the Kigali Agreement, and this agreement is in news because 18th of August we have seen that Union Cabinet led by Prime Minister Narendra Modi has approved the ratification of Kigali Agreement by India. So, that is why it is in news. It is a very important topic. You need to have complete conceptual clarity related with ozone depletion as a yet another important global environmental problem. So, we are all set to start the discussion on ozone depletion. So, we will be talking about, right, we will be talking about ozone depleting substances, ozone depletion as a environmental challenge, right, as a environmental challenge. Ozone depletion as an environment challenge, and in this regard a historic agreement, that is Kigali Agreement, that is Kigali Agreement. And it is not only that we will talk about Kigali Agreement, but we will also discuss about the Montreal Protocol, the Vienna Convention, okay, and everything related with ozone depletion and what the world is doing. Okay. So, let me start the discussion. I do not know whether you are aware with the fact or not that ozone is very highly reactive gas, and with 3 atoms of oxygen. Okay. So, what is ozone? What is ozone? First you need to have this understanding that ozone, right, ozone is a highly reactive gas, highly reactive gas, and this gas is composed of, 3 oxygen atoms, 3 oxygen atoms. This is why, this is why O3, okay, is what is the way it is referred, or chemical formula, whatever may you say. So, highly reactive gas, it is composed of 3 oxygen atoms, right, and primarily, right, primarily it is natural, but even it is man-made. So, it is both natural as well as man-made, but primarily it is natural. And as far as natural ozone is concerned, you will find natural ozone in Earth's upper atmosphere, okay. Basically there is a separate layer embedded within stratosphere which is known as ozonosphere, where naturally occurring ozone is there. Okay. So, naturally occurring ozone you will find in upper atmosphere, mainly in stratosphere, whereas man made you will find in lower atmosphere, sometime ground level. So, you can say technically that it is in the lower part of troposphere, okay, lower troposphere, and this naturally occurring ozone which is in the upper atmosphere, in stratosphere there is a separate layer in the name of ozonosphere, it is good. So, we call it good ozone. And why we call it good ozone is what we will see. Whereas, the man-made ozone which we find at ground level, which we find in lower troposphere is what is known as bad ozone, as it has very severe, right, as it has very severe impact on human health. Okay. You will find it as a part of vehicular emission that ozone is released at ground level. Spray paints which we are doing, in that also you will find ozone is released. Even sometime, right, ozone is released through other activities, okay, through other activities. So, we have good ozone and we have bad ozone. When the ozone is slightly at height in upper atmosphere, in stratosphere, it is good ozone. But if it is existing at ground level, then we call it bad ozone, right, then we call it bad ozone. And as far as ground level man-made bad ozone is concerned, you will find that basically this is getting released from photochemical reactions. And photochemical reactions between two major class of air pollutants, air pollutant, and those two major class of air pollutant are VOC, and NOx. Okay. So, nitrogen oxides, okay, this NOx is nitrogen oxide. And when I am using the word VOC, it is volatile organic compounds. Okay. So, what I just want you people to remember that we have good ozone, we have bad ozone. Bad ozone which is found in the lower part of atmosphere, very close to ground, in the lower troposphere, and that has very severe ill impact on human health, and that is why it is known as bad ozone. And this bad ozone which is in the lower atmosphere, in troposphere, even within troposphere, in the lower part, very close to the ground, this is getting released as end result of photochemical reactions which is taking place between two major air pollutants, one side volatile organic compound and other side nitrogen oxides. So, whenever there is photochemical reaction between these two class of air pollutants, then there is release of ozone which get stationed in the lower part of atmosphere and has got very severe ill impact on human health, and this is the reason why it is known as bad ozone. But the ozone which is in upper atmosphere, in stratosphere there is a layer in which ozone is embedded within stratosphere. Many a times we are calling this layer within stratosphere as ozonosphere, and that is considered to be good ozone. And why that is being considered to be good ozone? Because of the fact that this ozone is preventing the harmful ultraviolet radiation. Harmful ultraviolet radiations to reach to Earth's surface. Had this stratosphere within which is ozonosphere not been there, then harmful ultraviolet radiations would have entered through the atmosphere to reach to the Earth's surface and would have given birth to similar very severe problems. But because of this ozonosphere, the harmful ultraviolet radiations are not allowed to reach to Earth's surface, and this is why ozone, this is why ozone in upper atmosphere, in stratosphere is known as good ozone. So, the ozone which is in upper atmosphere, in stratosphere, is naturally occurring variant of this highly reactive gas, whereas the ozone which is man-made and is near the ground in the lower troposphere is bad ozone, and that bad ozone is the end result of photochemical reactions which are taking place between two major class of air pollutants, and those two class are volatile organic compound and nitrogen oxides. Now, you need to have this understanding that we are primarily concerned about this good ozone. Why? Because gradually this good ozone, which is the naturally occurring variant of, that is getting depleted because of release of ozone depleting substance. But first you need to understand why the good ozone is good ozone, and normally you will find this ozonosphere within a stratosphere at an altitude of 15 to 35 kilometers. 15 to 35 kilometers, and there is a thin layer within a stratosphere, and that is known as ozonosphere. So, embedded within a stratosphere is ozonosphere, okay, and this is called good ozone. This is called good ozone. Now, what exactly you need to know, why this is good ozone, right? Why this is good ozone? At least all of you this much physics must be knowing that when we make sunlight pass through a electromagnetic prism, it breaks into various component. So, one component is, if we see the component of sunlight, so one component is visible light. One component is visible light. Okay. So, one component is visible light. Now, this visible light, right, this visible light when passed through electromagnetic prism, then it breaks into the 7 bands of basic colors, and in your childhood you must have studied about Vibgyor. Have you heard? Yes or no? Tell me, Vibgyor. Okay, visible light. Vibgyor, yes or no? Tell me. V is violet. Okay, I is indigo, B is blue, G is green, Y is yellow, O is orange, R is red. Vibgyor, 7 basic colors. Okay, yes or no? Tell me. This much science. Okay, this much science. Okay, and other than visible component in the sunlight, we also have, this side. यहाँ पर है आपका विवग्योर के वॉयलेट के तरफ अल्ट्रा वॉयलेट रेज, ठीक है, उसके ऊपर एक्स रेज, ओके, अल्ट्रा वायलेट रेज, एक्स रेज, ठीक है, गामा रेज, गामा rays. So, gamma rays, X rays, ultraviolet rays, then is the visible light, okay, visible component of sunlight with 7 basic color in the, with this Vibgyor, and then you must be knowing below this red is infrared, red, okay, then microwave, and then radio wave, These are the various components of sunlight. Within that, visible light, okay, then and if we see this arrangement, right, if we see this arrangement, so this arrangement is basically, if I have to put it like this, this arrangement which I have drawn, okay. This arrangement, if I have to explain for you, okay. So, this arrangement, if I see, this is in the form of increasing wavelength, first one, increasing this is in the form of increasing wavelength. Okay, so violet, wavelength is lesser. Okay, violet wavelength is lesser in comparison with red. Okay, in comparison with red. Okay, so this is in terms of, right, this is in terms of increasing wavelength, and this arrangement is in the form of, from down to top if we go in this arrangement, then it is in the form of increasing frequency. Okay, so this much physics, right? This much physics you all must have studied, a scattering of light. Okay, a scattering of light, Ben Johnson is saying very correctly. Okay. Now you just see, all of you, they are asking even in physics very basic question. You know what is the use of X-ray? Are you aware? Use of X-ray? Okay. What we use, for what we use for X-ray? If we want to see the status of bones. So, one of the diagnostic tool, the doctor will prescribe you, get the X-ray done. Okay, so why X-ray is used? Because X-ray can easily penetrate through the skin and flesh. Okay, but it cannot penetrate through bones. So, we will know the status of bones. Okay, so you just try to understand this increasing wavelength and increasing frequency. So, violet has shorter wavelength than red within visible light, okay, and violet has higher frequency than red. Okay. So, whichever is in the top has shorter wavelength but higher frequency, and whichever is in the bottom has wider wavelength but lower frequency. Okay, lower frequency. Is this clear? Now, because of this ultraviolet rays, if you see where it is ultraviolet rays. Okay. So, ultraviolet rays in comparison with visible light had shorter wavelength but higher frequency, and this is why it can penetrate, right. This is the reason why it can penetrate, and since it can penetrate, I hope this ultraviolet rays within this is what is not allowed by ozone layer to enter Earth's lower atmosphere. Okay, this ultraviolet rays are actually getting blocked by ozone layer, ozonosphere. Okay. And this is why it is considered to be, good ozone. You know why? Because, right, because any exposure to ultraviolet rays as far as human being is concerned causes skin burn, and prolonged exposure of ultraviolet rays causes skin cancer, right. Prolonged exposure will cause skin cancer. Any exposure will cause, right, any exposure will cause skin burn, right, any exposure will cause skin burn, and prolonged exposure to ozone will cause skin cancer. Prolonged exposure will cause skin cancer, any exposure will cause skin burn, right. It also cause, cataracts. I hope you know that there is a very thin layer of a soft cheesy material which develops over the iris, that is known as cataract. So, it also leads to cataracts. It also damages the immunity system of human body. it leads to impairing of immunity system, right, immunity system. Okay, it also causes, right, within the skin cancer, right, within the skin cancer, it causes one of the most fatal within the skin cancer, that is melanoma, melanoma. It is a very fatal, of all skin cancers. Okay. So, any exposure to ultraviolet rays will cause skin burn, prolonged exposure will cause skin cancer, and even within skin cancer, one of the most deadliest and fatal is melanoma. So, it causes melanoma, skin cancer. Not only that, it also causes cataracts, it also causes severe damage to immunity system of human body, and this is why it is considered to be very, very deadly. Not only this, right, not only this, this ozone also causes severe damage to it has ill impact on photosynthesis. Okay. I hope you know photosynthesis in plants. Photosynthesis is the natural process through which green plants prepares their own food, and they are the producer, primary producer. Photosynthesis, you must be knowing that during this process carbon dioxide is absorbed from the atmosphere, water is absorbed by the roots, taken to the leaf zone of plant, where in green leaf we have chlorophyll. So, with carbon dioxide, chlorophyll and water, plant is able to prepare its own food, and during this process of photosynthesis, oxygen is released, and this is one very important thing through which we are maintaining the carbon oxygen cycle. And not only that, the food supply, the food chain. So, photosynthesis, can you write? Okay. So, there is ill impact on photosynthesis, and thereby it adversely impact the food supplies. It adversely impact the food supply. Some very sensitive crops are damaged because of ozone, particularly like soya bean, okay, and many other such crops, right. So, it is having ill impact not only on human body, but it also has ill impact on plants, and particularly in plants it is impacting the photosynthesis, and thereby, right, thereby the yield will go down, crop yield will go down, production of food grain will come down, food security will be adversely impacted, it may induce hunger, malnutrition among human population, and can disrupt the food chain. So, lot of ill impact is there if ultraviolet rays are able to reach to earth's surface. And my dear friends, some among you, and I am not using the word girls, even boys these days are very, very look conscious. Okay. So, if girls want to look beautiful. Even boys are equally interested in looking, handsome. Okay. So, why I am telling you that you must have seen that cricket players, particularly in Australia or in England, when we'll play 5-day test match, they will put sunscreen on their face. And why only cricketers? When some of you will qualify this exam and will choose IPS, 1 year you will undergo training in Hyderabad, and during summer when your physical training will go at Sardar Vallabhbhai Patel National Police Academy, and you will have to do parade, you will have to do drill, you will have to do physical activities in open, in sun, then you will find many probationary lady officers and other officers will put sunscreen. And when you go to purchase sunscreen, one very important component what we see in these sunscreen, UV protection kitna hai. Okay, because they know that when they are working for a longer duration in sun, there can be some exposure to ultraviolet and that can have ill impact on their health. Skin burn, dark patches will appear when you are in sun for longer duration. Dark brown color skin will turn because of sunburn. But if there is prolonged exposure, then there will be skin cancer. And this is the reason why. You must have seen earlier when farmers used to work in the agricultural field during summer, they will cover their face. Even if dusty wind is not blowing, they will cover their face. Why? To protect their skin from exposure to ultraviolet rays. Okay. So, have you understood that why good ozone is good ozone? Because it is preventing harmful ultraviolet rays to reach to lower part of Earth's atmosphere, near surface of Earth. Only because of this ozonosphere, ultraviolet rays are not able to reach. Otherwise, if they are reaching, it will cause a lot of problem to human health as well as entire ecology. Why? Because it will disrupt the process of photosynthesis, thereby it will adversely impact the primary producer, that is plants, and the consequential ill impact of it will be on food chain. When it comes to human being, it will have deadly impact on food supply for them, and so on and so forth. So, give me the clearance. Have you understood what is ozone, what is good ozone, what is bad ozone? Air quality index may we also see ozone, but that is what we are seeing, bad ozone. Yes or no? And it is the ozone layer in stratosphere which is preventing actually the harmful ultraviolet rays to penetrate through it and reach to Earth's surface or reach in lower atmosphere. That is what is, that is what is ozone. All of you, have you understood? Right? All of you, have you understood? Yes or no? Tell me. Yes or no? And सबसे ज़्यादा जो ये जो है ना आपका this one bad ozone ground level में, ये आपको smog में मिलेगा. So smoke plus fog, right? Where we have smoke and fog together, smog. Urban smog में you will find, that this ozone is there, because that smoke in urban area is primarily on account of what? Very high intensity of, release of vehicular emission, or some industries are there on the outskirts of cities from where the harmful smoke is being released, and if there is foggy conditions, particularly during winter, they get trapped and we see a smog in their region. That is, that is where we have, bad ozone. Okay. So, two-way, bad ozone, when volatile organic compounds are photochemically reacting with nitrous oxide, that is also causing, bad ozone, and also smog, urban smog, bad ozone, but when it is in troposphere, ozonosphere, that is there. So, anyway, now once you have understood this ozone concept, basics of ozone concept, then what I would like you all to know that, towards the last 2 decades in 20th century, humanity started realizing the importance of ozone sphere. Okay. And how we realized? We realized that this is very, very important for us. And then we also realized that there are, because of human factor, large quantity of ODS is getting released, and that is what is causing destruction to ozone layer. And then we realized that there is a need to protect ozonosphere. There is a need to preserve ozonosphere, and only way we can protect ozonosphere is by phasing out the release of ozone depleting substances. Okay. So, just write down, in early 1980s, humanity realized and understood the importance of ozonosphere, which is embedded in stratosphere, which is embedded in stratosphere, full stop. Even we could realize that there are certain substances which are being released because of human activities, are damaging, are causing thinning of ozonosphere for creation of ozone hole. Thinning of ozonosphere for creation of ozone hole. So, what is ozone hole? Ozone hole is thinning of layer of ozonosphere. Okay. So, what we realized in early 1980s, that there are certain substances which are being released because of our activities, whatever activities we are doing on surface of earth, through those activities, what is getting released in earth's atmosphere? These substances which are causing thinning of ozone layer, and this thinning of ozone layer is known as ozone hole, creation of ozone hole. Okay. So, hole is getting created, hole, ozone hole. Damage to ozone layer. Okay. And those substances, right, those substances which can cause damage to ozone, right, damage to ozone, they were termed as ODS, meaning ozone depleting substance, ozone depleting substances. And within ozone depleting substances, right, we were able to find that the biggest culprit is CFCs, then HCFCs, then any other halones, then methyl bromide, okay, methyl bromide, then carbon tetrachloride, CCl4, carbon tetrachloride, then methyl chloroform, and so on and so forth. Initial our understanding about ozone depleting substance were limited, methyl chloroform. Okay, CFC, I hope you know by now, we have already discussed about CFC. This is chlorofluorocarbons, chlorofluorocarbons. Okay. This is hydrochlorofluorocarbons, carbons. Okay. So, these are ozone depleting substances, these are ozone depleting substance, and many of them are even greenhouse gas. Okay. So, these gases or these substances are dangerous, not only because they cause damage to ozonosphere, but they also have one tendency, and that tendency is to trap the outgoing long wave terrestrial radiation, and thereby they will keep the atmosphere warm, and if their concentration is increasing in the Earth's atmosphere, then gradually the temperature of Earth's atmosphere and surface will go higher, which is yet another environmental problem with the name global warming. So, they are ozone depleting substance, they causes, right, they causes severe damage to, the ozone layer. And what I would like you to remember, right, what I would just like you to remember, it's not only that, you know, once they enter, these are released, okay, these are released, then continuously they will keep on causing damage to ozonosphere, continuously they will cause damage to ozonosphere. I will give you a chemical formula, this will, you know, chlorine, which is one of the halones. Okay, so, if chlorine will enter, it will react with ozone, and this reaction will lead to the formation of chlorine oxide plus oxygen. Now, what will happen? This chlorine oxide, it will react with another variant of oxygen, okay, another variant of oxygen, and this you just see again what it will lead to, chlorine plus 2O2. Okay. Again this chlorine is there and this cycle will continue. So, this will keep on damaging the ozone. You just see, first chlorine is reacting with, and ozone is a highly reactive gas. So, it is reacting with ozone and chlorine oxide and oxygen, okay, chlorine oxide and oxygen. Then chlorine oxide is again reacting with ozone, okay, again chlorine and oxygen. Now this chlorine again will, and this cycle will continue, right, this cycle will continue and continuously, continuously it will cause damage, right, continuously it will cause damage, okay. And one thing what we realized later, one technical thing what we realized later, okay, and this is something, right, this is something which you need to understand, that we found when we started, because ozone created curiosity among scientists and climatologists. So, we could understand what is ozone, what is good ozone, what is bad ozone, what is the role of ozonosphere, how it is preventing, and which are the substances which are causing damage to ozone. And then we could even understand that ozone depleting substances are also, most of them are also the greenhouse gas. So, their increasing concentration in Earth's atmosphere can be disastrous. All these things we realized. But then we realized that more damage is happening to this ozone layer in high latitude, particularly over poles. And over poles what we saw, that during winter there will be thinning of layer. But again, right, again during spring season, that thinning which has taken place, that will get repaired, right, that will get repaired. So, two things are there you need to understand. One is, because of our, because of we allowing the release of ozone depleting substance, the thinning is happening. But there is one natural process through also, through which also thinning is happening, and that thinning is happening over Antarctic, okay. So, ozone holes, okay, over polar region, okay, and particularly this polar region, if we see Antarctic, Antarctica, if we see, okay. Now, particularly during in Antarctica, we see what, during the month of onset of winters. So, September, October, November, December, in these 4 months thinning will take place, okay. And this thinning, and similarly you know very well that in the southern hemisphere when is the winters, right, in southern hemisphere when is the winter. So, this is, this is natural, and this thinning which is happening over polar region, and in case of Antarctica during winter, September, October, November, this is on account of, this is happening on account of special meteorological and chemical conditions. This thinning is happening, special meteorological and chemical conditions. Okay. So, special meteorological and chemical conditions we find that there is a natural thing which happens over pole, right, over pole, and that leads to thinning, right, that leads to thinning. Now, if you ask me what is that special meteorological and chemical condition which leads to thinning, so that is because of polar vortex. You must have heard about polar vortex, and don't ask me what is polar vortex in general geography. Joe sir would have explained you in detail polar vortex. Okay. So, because of polar vortex, so when winter arrives, a vortex of wind is developed, a vortex of wind is developed, and because of this polar vortex, it leads to the formation of PVCs, polar vortex clouds, right, polar vortex clouds. Okay. Now, what actually happens with polar vortex cloud? I hope you are aware with the fact that a strong wind will be blowing in the polar area. So, ice will be turned, ice of the surface will be turned into a small dust particles, and over these small dust particle which will be scattered and will be moving in the wind, along with the wind, in this polar vortex cloud PVCs, right, you will find them moving in PVCs. Now, over the surface of these ice crystals in the clouds are, are nitric acid, sulfuric acid mixtures, okay. And what happens, what happens, that this is what, when the spring season will come, then ice will evaporate, okay. And when this is floating in upper, you can say a stratosphere, okay, these ice particle within this polar vortex clouds, okay, with ice crystals, small ice crystals, and above the ice crystal, above the surface of the ice crystal, you will have the mixture of nitric oxide and sulfuric acid that causes, damage to ozone layer, with which thinning starts. But when, right, but when temperature will begin to rise, when temperature will begin to rise, temperature will rise during spring, when temperature will rise. Now, then what will happen? Ice evaporates, ice evaporates, and these chemicals will be brought down over the surface, and then, the recovery of ozone layer will start, right, recovery of ozone layer will start. But this is a natural process which we were able to understand in late 1980s, that over Antarctic, over Arctic, over polar region, during winter, thinning of ozone hole will take place, and with onset of spring, repair will start, okay. But in all other parts in high latitude, what's happening? Because of our activities, ozone depleting substances are being released, and these are causing damage to ozone layer, because of which thinning of hole is happening. Now, one thing which I would like to tell you, let me put it like this. When it comes to ozone depletion as an environmental problem, what response the world has given? The response which the world has given is very prompt, adequate response. The moment it was realized that our activities which are leading to release of ozone, ozone depleting substance, now the world could sense that the first and the worst to be affected are high latitude countries, developed countries, European countries, Canada, America, United States of America, these are the countries which are getting first and worst affected because of thinning of ozone layer. Then what will happen? This is the crude and the harsh reality of life, that status of the victim will, right, status of the victim will govern the response of the world. This is sad, this is bad, but this is the crude and the harsh reality. I keep on giving an example that if somebody will slap a rickshaw puller on road, neither the society nor the state will give proper response. But if DM Sahab pe, even if somebody will shout, the whole district administration will respond. So what is happening? When it comes to global warming and climate change, first to be affected is, poor Afro-Asian countries in lower latitude near equator. But when it comes to ozone depletion, first and the worst to be affected would be higher latitude developed world. अभी आप वैक्सीन में भी देख लो, the privileged high latitude has, been successful in administering more doses of vaccine than the poor low latitude countries, or the West has been, east west divide hai, north south divide hai, high latitude low latitude divides are there. Yesterday there was a terror attack in Kabul, 13 US service members died. Death is a death, but 190 Afghan civilians have also died, and we condemn every death. But you see, what is happening in our immediate neighborhood is a cause of grave concern for India. ISIS-K has taken the responsibility, and now there is a fear that in Jammu and Kashmir Union Territory there can be security problems in days to come. Attempts of infiltration may increase. We will have to create a very robust security system along LOC, as well as we will have to strengthen the intelligence apparatus, because Jaish-e-Mohammed, Lashkar-e-Toiba, other militant outfits of Jammu and Kashmir now will get the support from Pakistan state and non-state actors, and the state actors of Pakistan will support these militant outfits through Taliban and ISIS-K. And this is the reason why we have no other option than to strengthen the apparatus. And not only we will have to strengthen the security apparatus, but we will also have to reach out to our own brothers and sisters in Kashmir Valley who for some or other reason are angry because of some or other political decisions. So before they are being reached by elements which are hostile to India, let Indian government reach out to them and communicate them powerfully that whatever has been done, it has been done with very good intention to accelerate the pace of development in the region. Okay, so we need to understand many things. So what I was just trying to say, that when we realized, when the world realized that ozone depletion on account of increasing concentration of ODS is a big global environmental challenge, then the response of the world was not only quick but very prompt. Developed countries said that all countries in the world will have to phase out, all countries in the world will have to phase out the depletion, phase out the release of depletion of ozone depleting substances. They will have to phase out, and they will have to, for that, what you need. They started asking very openly to developing countries, what you need. You want transfer of technology, we will transfer the technology. You want money, we will pay you, but we will ensure that you are not releasing ozone depleting substance. But when it comes to global warming, the first and the worst to be affected would be countries from Asia and Africa near equator. So only thing what is happening, almost 30-40 years we are only talking. Earth Summit 92, serious talks started. We signed Kyoto Protocol, Commitment Phase 1, Commitment Phase 2, now Paris Climate Agreement. But still we are just talking. Less action on ground. And the ground reality you know, because now you have already studied the IPCC 6th synthesis report, the first working group report which has been submitted. But when it comes to ozone, यहाँ पे सब कुछ हो रहा है. What should be done to repair the damage? Okay, so let me put it like this: when ozone depletion as a problem was realized, okay, as a problem was realized, immediately, a meeting was called in 1985 and this meeting was held at Vienna. Okay, and then in 1985 the meeting which took place at Vienna concluded with Vienna Convention. It concluded with Vienna Convention. Okay, and this Vienna Convention is very simple. This is about protection of ozone. This protection of ozone. Okay, so every party agreed that we will protect ozone, but how to protect? No, how to protect? No agreement, but only blame game. Okay, therefore, a meeting was called, a meeting was called in 1987. In 1987, and this time the meeting was held at Montreal. Montreal is in Canada. Meeting in 1987, the meeting was held in Montreal. Okay, and during the meeting was the signing of, during the meeting was the signing of historic Montreal Protocol. Historic Montreal Protocol. Okay, so what happened? What happened at Montreal? What happened at Montreal? A protocol was signed. Okay, and this protocol, Montreal Protocol, is basically in the form of a intergovernmental treaty. Intergovernmental treaty. It is in the form of a intergovernmental treaty. So, governments of different countries have signed this protocol, they have agreed, right, they have agreed, and this protocol, right, this protocol is very simple, okay, this protocol is very simple. What is the protocol? Now you see, it only talks about the phasing out of ODS, release of ODS. This treaty primarily talks about phasing out the release of ODS, ozone depleting substances. How we can phase out the ozone depleting substance? In a phase out manner, we have to, right, in a phase out manner, we have to stop the release of ozone depleting substance. So, very simple. So, Montreal Protocol is of 1987. This protocol was opened for signing, in September 1987. It was opened for signing in September 1987. And those who signed, they were called party to protocol, right? They were called party to protocol, and this protocol, came into enforcement on 1st of January 1989. 2 years later, it came into enforcement. Okay, it came into enforcement. Okay, and today if we see, right, today if we see, there are 197 parties to this protocol, which include 196 country and then European Union, the grouping, okay, European Union, the grouping. And even India is a party to both Vienna Convention related with protection of ozone and Montreal Protocol, which talks about phasing out the release of ODS. Let me just bring this to your notice, factual thing, that on 19th June 1991, India ratified Vienna Convention, okay, and on 17th September 1992, India ratified Montreal Protocol. India ratified, party to Montreal Protocol. No, sorry. India ratified, India became the party to Montreal Protocol as well. Have you understood? Right? So, very simple is Montreal Protocol. This protocol is in the form of an intergovernmental treaty, right? Intergovernmental treaty. And, and I would just like you all to remember this, right? I would just like you to remember this, that most of the policy makers and environmentalists are of the view, right, just write down, most of the policy makers and environmentalists are of this view, that Montreal Protocol is the single most successful treaty related with environment, treaty related with environment, and